Okay, I'm going to get started because I have 25 minutes of stuff and I want to try to get through it. So I'm going to ask that we leave questions until the end because otherwise I don't have a chance of getting through it. And also, tomorrow there's a office hours in the garden room at 4 o'clock for the kernel validation team. We'll be in there as well as some of the other teams if there are questions there. Also on Wednesday there's a follow-up session which is more of a feedback session. So that's also a great place to get questions answered. So write your questions down, and you can also find me in the hall. You can email me or you can tweet at me. I love getting emails and tweets and stuff like that, so however you want to reach out would be great. So I'm here to talk about Linux kernel functional testing, what I'm calling 2.0. It's really just sort of the status and where we're going with it. So let's get started here. So in brief, what LKFT is it's 4 architectures. It's a continuous integration system for the Linux kernel. We cover 4 architectures, 5 physical boards, 4 virtual environments with QEMU. We focus on long-term stable branches, 4.4 through 4.19. That's sort of where we put the most of our effort, but we also test the latest stables, mainline, next trees. We run a variety of test suites, including LTP, libhuge, TLBFS, perf, video for Linux, KVM unit tests. S-Suite we run as an IO benchmark tool for BFQ, and K-self-tests, of course. So we run a total of about 25,000 tests on every kernel that we test. LKFT has been a project for about 2 years. You can see the cumulative number of tests we've run here. We've run about 68 million, and we run about 1 million tests every week. That's on upstream Linux. We also work on Android, so there's a different team that does Android, so I'm not the authoritative person on Android, but Android's running way more tests than we are. They actually ran 5 million tests this week. I just went and looked. Android has a lot of tests in it, so that's part of the reason. For the purposes of this talk, I'm going to break down LKFT into 4 sections. We have the build part, we have the provisioning and booting part, we have the testing part, and then we have the reporting part. I'm going to go through each of those phases and talk about how things are and where we're going in LKFT 2.0. Yes, before I do that though, I want to just say that in software, everything, we stand on the shoulder of giants, right? And so everything we have in LKFT exists because of a lot of hard work of a lot of people, some of which I'm going to criticize in a moment, and I just want everybody to understand that I'm doing it with respect. Also, I sometimes express myself with GIFs and emojis, and so you'll see some of that. Okay, this is how LKFT builds work. They're open embedded based, they're Jenkins based. We do a full open embedded build for every single kernel board combination that we test. So it's about 6 builds for every kernel version, and each build is a full operating system, including the toolchain and everything. We have a fixed and shared build capacity. So we have a set of build servers. They're shared with other groups that are also doing builds. We have a repository with all of the build scripts, with all of the jobs defined, and things like that. And so we have a couple Jenkins job files actually for each kernel branch that we test. And here's just a screenshot of what the Jenkins interface looks like. Those are a couple builds. So what are the problems with this environment from my perspective? Builds can be slow. Because we're doing the full operating system every time, it takes a lot of work to optimize that and get it to be fast enough. And we've done a lot of that work, and it is pretty fast, but it's still doing a lot of work. Builds can be queued because we have a fixed build capacity. Sometimes you have to wait in line. Ancillary kernels require a full build. What's an ancillary kernel? So sometimes we get requests to build something into our kernel that we don't want to build in for all of the test runs. We just want to do a separate kernel with a separate config, like KSAN, for example, is a common request. Those are hard to do because we have to do twice as many builds in order to do that. And since each build is a full operating system, it's a bit costly. So as a result, we don't do that. The builds are hard to reproduce outside of Jenkins because it's tightly coupled with Jenkins and because we have a repository with all of our stuff in with Jenkins. It's hard to reproduce them outside of the Jenkins environment. Changes to our Jenkins jobs are difficult to test because we just have a production Jenkins environment, and it's a little bit of an overhead to set that up locally to be able to make non-trivial changes. Finally, and I think maybe the biggest, is that the kernel builds are built using open embedded and with bitbake. Our primary users are kernel developers, not open embedded developers, and so they don't use bitbake, and they don't necessarily want to learn bitbake in order to understand the output of our builds. So we have a build log. It's really big. We have our config is built through open embedded recipes, so we don't have a config fragment we can point to. And when we have a build failure, there's a possibility that it's a kernel build failure, and there's a possibility that it's not. And so sometimes we send out false failures and have kernel developers digging into our huge logs trying to figure out what failed when it may very well not have actually been the kernel. So where are we going? We're going to kernel CI style builds. Kernel CI builds root file systems separate from the kernel. So they're detached from each other. The root file systems can build at their own frequency, and the kernels build on demand. The kernel builds are independent and native, so the kernel builds are what a kernel developer would expect. And kernel CI uses Docker-based build environments so that the builds are reproducible anywhere using the same tool chain and things like that. We're going to scale build servers dynamically. So when there's no builds running, we don't have any build servers. When there's a lot of builds running, we'll have a lot of build servers. So we eliminate a lot of that queuing cost that we currently have. And our artifacts will be stored in S3 and served from S3 directly, which eliminates a layer from our environment. We're deploying Jenkins. We're still using Jenkins, but we're deploying it with GitLab CI. So it's a ephemeral Jenkins that's dynamically deployable. So what do we get? Build times are fast and consistent. Ancillary kernels, so we can build additional kernels with specific configs for specific tests if we need to. The builds are easily reproducible with a one-liner outside of our environment using the Docker container. We have a staging environment for Jenkins, so we can make changes safer and easier, and large-scale changes are easier to test. The kernel build is simplified, so users will understand how it's being built. Artifact hosting doesn't have a layer. It doesn't involve servers, so it'll be a little more reliable. And we're compatible with kernel CI, which is great for kernel CI and us. Okay, moving on to boot. So our boots currently are U-boot or fastboot, and depending on the board, some of the boards use a file system image with the kernel built into the image. And this is and the picture here shows our QEMU x86 job with the artifact that we pass in, which is the kernel image. Juno flashes its firmware every time to guarantee that it's correct, and our job templates are in that same directory with all of our Jenkins jobs. So what are the problems with this approach that we've run into? Bisection is just a pain in the butt in our environment because the artifacts you're passing to the Lava jobs are different depending on the environment that you're testing, depending on the board that you're testing. And so some boards you need to rebuild a root file system in order to test a different kernel. That's really costly if you're a casual user and you want to just be able to make a change to a kernel and test it. Fastboot flash is slow, and it's expensive on the dispatchers. Juno wastes 10 minutes on every job, and the Jenkins job generation is not portable, so it's locked into that Jenkins repository. So if you are not using Linaro Jenkins and you want to use LKFT jobs, you have to do a lot of extra work to try to get those out. So where are we going? All jobs should take a root file system parameter and a kernel parameter. That way the kernel parameter can be changed for each device type, and that makes reproducing things easier as a user. If a rootfs is required, we can build that at runtime via Lava. Fastboot flash is avoided where possible, just for the performance impacts. Use NFS-based root file systems where possible. And the Lava job generation is being extracted to its own tool called Lava test plans. So what do we get? Better fastboot provisioning options. So fastboot has historically been has been sort of the difficult thing to integrate in our environment because of the requirements it has, but we have more options now. So there's something called fastboot NFS that we're working on implementing in Lava so that we can NFS boot from using fastboot. We can build the image inline. Like, worst comes to worst, we can just have Lava build the fastboot image inline in the job. It's less efficient from a technical engineering perspective because you're building that root file system every time. But from a user perspective, you don't have to worry about it. You don't have to build it outside of Lava. Lava job generation is shareable and portable using that repository I just mentioned. Bisection becomes easy. Easy is in quotes because bisection I don't think is a trivial problem. But since we're compatible with kernel CI with our booting as well as our building, we can collaborate with kernel CI, and kernel CI has done a lot of work on bisection and continues to do work on bisection. All right, test design. Let me check my time here. I'm doing good. So we have a repository called test definitions in GitHub. This is where we wrap all of the test suites that we run so that Lava knows how to run them. We build the tests into our root file system. So our root file systems come with the test. We don't deal with that at runtime, generally speaking. Although for k-self-test it is handy because we build everything together. It's handy for k-self-test because k-self-test you need to build with the kernel, and so we can build the kernel and root file system at the same time, and it all works out really nicely. That's something we're losing. And we use a single root file system for all tests. And I just want to say a thing about test definitions because I think there's some misconceptions about it. It's a general purpose test suite wrapper. So it's above test suites. And it's not coupled to LKFT and it's not coupled to Lava. Each of these tests has a script for how to run the test, and then it has a YAML file that lets Lava know how to run the script. So it does work outside of Lava, and people do use it outside of Lava. So what are the implications? Actually, I think test definitions are done really well. So we don't have a lot of changes that we're looking to make here. Sometimes we hit space constraints on our root file systems if we're flashing them. And since we only have one root file system, sometimes we've had to decide what goes in and what can't go in. So what are we doing for LKFT 2.0? K-self-test will have to be built differently. So we have to build K-self-test at kernel build time, and we have to get it into the root file system at runtime. So that's going to be a little bit trickier than what we currently deal with. We can have different root file systems, though. So if we have a root file system for a specific test because it's bigger or something like that, we can do that. We can mix and match kernels and root file systems. That's a really powerful thing. We're looking to improve the parsing of our test jobs. So one of the things that are hard to catch right now for us in our environment are kernel oopses, warnings, panics, and things like that. So the picture here is a pull request in Squad to do parsing of the log to capture oopses during the test runs. Likewise with tap support, right? A lot of tests and test suites are implementing tap support. Tap is Test Anywhere protocol. It's a standard for how the output of a test should look so that you can parse it in a standard way. And that's being added to a lot of test suites. It exists in a lot of test suites, and we don't currently take advantage of it because we have existing parsers that we wrote before tap was prevalent. So what are the implications? I'd like to parse tap directly in Lava and the kernel log parsing in Squad that we just talked about, so we can more directly drink from the data hose and hopefully have better luck than this kid. Okay, finally, reporting. So this is the least baked of all of the things. Building and booting, we're well into that work, and we have a lot of it working. For reporting, we're just starting to think about what we should be doing. So currently the way it works is we have templates. They're defined in squads. Squad QA reports is where our test results go. And so we have templates in there, and at the end of all of the tests completing, it sends the data through a Jinja template and then emails a list of people. We track our bugs at a Bugzilla instance at bugs.lenauer.org. We have a QA reports known issues. So Squad has a concept of known issues that allows us to mark a test result as a known failure or as a known intermittent failure on a per test, per board, per branch basis. And we do that so that we can avoid the noise of tests that we know that we expect to fail or tests that sometimes fail. And so the repo there has our automation for that. We do have some reports for stable, for example, where we generated it using the Squad API rather than letting Squad do it directly. Most upstream reports and most bugs, though, are manually curated by our team. The Jinja here is some of the more fun Jinja we've had to write in order to try to get the report to look kind of how we want it to look based on the data. Okay, what are the tired implications of reporting? It's generic. So we have one list of people and we have one template per branch. So everybody better want to see the same data because that's the data they're going to get. The reports are naive. So it's just taking the data from the most recent test run and it's sending it through a Jinja filter, formatting it, and sending it out. There's not a lot of ability to do more clever things. So like I said, there's limited ability to customize it for the audience that you're sending it to. We have a lot of data. We have so much data in Squad, but it's kind of locked in the database. And so as a result, the signal-to-noise ratio isn't always great in our reports, which is why we end up having to do a lot of things curated manually. So where are we going? I would really love to find a better reporting layer that is basically downstream of QA reports of Squad. So that we can do things like look at the data across branches, look at it across time, and generate fine-grained custom reports based on the audience, based on the person receiving the report. Developers ought to be able to come to us and say, I would like to see information about this test or this test suite or this board across these branches, and I want to see that daily or weekly or in real time after every time it runs. We recently started a project at Plumbers, this happened, called the Kernel CI/DB project. I don't know if that is like the official title, that's the GitHub name. And the idea is that we can aggregate our results from the different testing groups into a centralized cloud database that we can then do queries on. I'd like to be able to automatically identify flaky results. These are sort of the bane of our existence, and if we could send a result that says we're 25% sure this is a regression, or we're 85% sure of a regression, that gives the recipient a lot more information about the data they're looking at than what we currently give. And so we have an initiative that we're just starting to solve some of these problems. So we hope to achieve higher signal-to-noise ratio. We want to be able to support individual developers and their individual preferences or their group's preferences, the mailing list preferences. And we need to be able to slice the data as we want. So maybe they care about certain subsystems, maybe they care about certain tests, maybe they care about certain boards. We should be able to deliver the information that people want, how they want to see it. Okay, I'm wrapping it up here. Top 5 takeaways. Kernel CI and LKFT benefit from each other more. So we work a lot on Kernel CI, but it's always been a very separate sort of thing than LKFT because we didn't share a lot of the common components. We'll be sharing a lot more now, so that'll help. It'll help both of us. Kernel builds are as developers expect, so it's less magic is going into our builds. Cloud scale kernel build capacity, so we'll be able to build whatever we need to build without capacity constraints that we currently have. It'll be a lot easier for us that are doing triage on these results to find the root causes. This gets back to bisection, but basically it'll be a lot quicker for us to figure out what's going on with tests. And hopefully the reports become more useful to users. Okay, so if you didn't get anything else, I really just want to be able to say yes a lot more to the requests that we're getting. Can you send me this report? Yes. Can you test this kernel option? Yes. Can you run this test suite? Yes. I want to say yes more. And I think that's it. Maybe we do have time for questions. 5 minutes. Naresh has microphones here if anybody has any.
Yeah, you mentioned maybe adding a confidence score to regression reports. What aside, was it just the number of instances of observing a failure out of a total that you envisioned going into that data, or were there other things that would influence that score as well?
I think if a naive approach, I don't know how naive it is, but if you looked at we know the test we know the test history on a particular branch, and we know the test history across branches and across time. So if you looked at the test, you would be able to detect if it was going back and forth a lot. And I think that that would reduce the confidence. That's my impression. I did talk to somebody at Red Hat, at Plumbers, and he sent me a project that is doing this. He sent me an implementation that's, I think it was, I could follow up with you if you were interested in that, but that's what I was going to try the next time I give it a try. Yep.
What's the current latency between a kernel branch getting uploaded and you start to test it and then getting the results sent out, and where do you think you can get with a new system?
Well, I mean, it's a little bit of a hard question because it depends, right? The builds happen
the best case.
Best case for an automatically generated report. Naresh, I don't know, 4 hours, 6 hours? 6, Daniel says. What did you say?
4 hours.
4 hours, 4 to 6 hours.
4 hours, including 25,000 test case completed.
Yeah. Daniel's eyebrows are raised, so somewhere between 4 and 6 hours.
Yeah.
So a couple of questions. One is with respect to 2.0 status. I mean, can you give an indication in terms of each of those phases, what is done, probably what is yet to do? And the second question would be, I've forgotten. I'll get back to you.
Okay, I'll answer the first one while you think of the second one. I didn't have time for that in this talk, but basically we have the Jenkins environment deployed into AWS. It's building kernels, and we can generate the jobs for one board. So we currently have it running on Juno, on mainline, and it's working. The work that is going to remain after Connect here is to migrate everything over to it. So that's for the builds, and that's for the builds. For the boots, we've solved the problem with Juno and flashing. For some of the boards, we still have work to do in order to change the jobs to not require a root file system. So that's work that remains to be done. There's not much to do in testing, and in reporting, like I said, we're just getting started.
Second question was mostly with respect to sharing of assets. So I do see kernel CI might be able to probably generate me the kernels, which may not be possible currently with LKFT. So could some of those build artifacts be consumed by LKFT and then kind of try to leverage kind of both the capabilities from both these systems?
So all of LKFT is public. Our artifacts are all public. Is that what you're asking? If you wanted a general build, we would just put it in kernel CI.
Okay.
Does that make sense?
The question is that kernel CI is already doing builds. So why can't LKFT pull those builds instead of you build it?
That is a good question. And the reason is that there was a lot of work to do to get it to this point. For example, with Open Embedded, we want to keep using Open Embedded. Kernel CI is all Debian based. So that was one thing that we had to work our way through. We have a much larger kernel fragment than most kernel CI builds, things like that. So we're working it all through on our own infrastructure and then upstreaming things as we can.
I had a question related to the data that you generate, your logs. You were talking about you wanted to improve the kind of signal to noise ratio of your logs and the pertinence to each individual recipient of that log. Are the data sets available for people to download? Like, do you publish all your logs in such a way that I could basically grab it all like a giant blob and do whatever big data stuff I wanted on it? And would I be able to relate it back to patch sets? Would I be able to collate a log against a kernel baseline and figure out what patches went in?
Well, so we just test the Git branches. We don't test patches unless they're in Git. So with every set of jobs that we have the kernel version, the branch, and as long as you're on a branch that didn't get rebased, like sometimes we test stable RC and those get.
No, sure, but I should be able to generate the log history from the versions you give me.
But it's all based in Lava. All of our logs are available in Lava, and so we can certainly make they're all available. I don't know what would happen if you tried to like slurp them all in. You should talk to us first. But certainly we can do that.
Would you be the person to talk to about log refining and kind of post-processing and that stuff?
Yeah, let's talk after.
Great, okay.
And I can put you in touch with the right people depending on the specifics.
Yeah, we are not merging any patches and building it, so it's all about fetching the particular tree. So if you have a tree gen, we are just going to the tree and fetching it and building it. So it's like after the results comes up, then we have a mechanism to test, like compare the results from last version to the current version and see is it improved or not improved, or is there any degradation.
Sure, it's all post-merge. Does that make sense?
Yep. Anything else?
Yeah.
Maybe we have time for one more. John?
So I know things are focused on OE, but are there any Android ambitions with LKFT?
Any what?
Android ambitions?
Omissions?
Android ambitions, so
Ambitions.
Yes.
So the Android guys are really interested in using this, and I think after we like bake it a little bit and get the kinks worked out, then we'll be able to add the Android trees as well. I don't see any reason why we shouldn't be able to do that. Okay, well, thank you very much. I appreciate it.